Hello folks, welcome to my channel Java Demystified by SSR. Here comes the question number 19. What is abstraction in Java? Let's demystify this. So abstraction is one of the major principles of object-oriented programming. And abstraction is an act of representing essential features and hiding the irrelevant details. So here it is given, abstraction is a process of hiding the irrelevant details and exposing only essential features of a particular object. So the concept here is abstraction is an object-oriented principle through which we can actually focus on the essential features rather concentrating on the background details. As an example, if you see a car, a view of car by any person actually is this, the bottom car actually. So we will see what is the color, what is the sitting capacity, what kind of fuel, how much mileage it will come, what is the price, what are the safety features. All these things actually we'll see whenever we look at a car. So these are the essential features for a common man. But what are the background details of the car? If you see this, the top car actually, so there are several other things like engine, how engine is working, what components are associated with that, how the basement actually is prepared for that particular car, how the wheels have got aligned. Okay, so all those background details usually common man doesn't concentrate, right? So abstraction also says the same. So how it actually helps in object-oriented programming? Abstraction helps us to understand a system easily. A complex system cannot be understood in its entirety. So we have to understand it by modeling actually. So in that process, the abstraction helps us. We abstract things, we identify what are the functionalities, we list out the functionalities. This has to be done, this has to be done, this has to be done. So that means what has to be done. Initially, we don't bother about how it has to be done. So abstraction focuses on what the object does instead of how it does, and through which we can actually manage abstraction. So abstraction helps in understanding a complex system. Other example, so if you go to an ATM, we actually go to ATM to withdraw some money or deposit or check balance or get the mint statement, etc. So we just insert the card and then we will get the money or deposit money and we'll come back. We will not be discussing in detail about the background details of that ATM, and we don't bother about it. So how card reader works, how cash dispenser functions, how my bank account details are stored, in which server actually it is stored, what is a third party, what web servers, application servers involved, what is the background technology that is running. So these are all irrelevant details for a person or a customer who uses actually that particular bank. So there are people who has to take care of that implementation details. So now there is a clear distinction what actually you want and how it has to be implemented. Abstraction focuses on what you want, what has to be done, what are the functionalities of the system, and how it is implemented is left for some other components. Okay, so an example for Daniel's score. So we see actually the essential features only, and engine functionality, accelerator functionality are not for a common man who is actually looking at a car. Now let's understand these things with a program and how Java handles this abstraction. So in Java, we have two entities which actually achieve this abstraction. We have something called abstract class and we have interface. Yeah, so this abstract class actually achieves 0 to 100% of abstraction, and interface, through interface we can achieve 100% of abstraction. So these are the two implementation units for abstraction in Java. So as an example, if you see here, I have a code snippet for this particular abstract class. So I have a class ATM. What are the functionalities of an ATM? One can check balance, one can withdraw money, one can deposit money. And I have actually made all these things as an abstract. Because this is a method, check balance is a method, there is no definition for it, there is no implementation for it. And for deposit also there is no implementation, withdraw also there is no implementation. So the method just declared without any implementation, even zero implementation. Those methods actually called abstract methods, and those methods must have to be associated with a modifier called abstract. This is just a functionality that the ATM has. Withdraw is a functionality, deposit is a functionality. Whereas if you see, there is a method called dispATM, so it's a public method, it returns void, and it has some behavior, some implementation. So ATM details are getting printed. Okay, so this method actually is a concrete method. But rest above three methods are abstract methods. And in a class, if you have at least one abstract method, that class must be made as abstract. And an abstract class cannot be instantiated. That means you cannot create an object of it, even though you have some partial implementations. So an abstract class will have partial implementations. It achieves 0 to 100% of abstraction, and it will have partial implementations. So here, out of 4 methods, 1 method is implemented and 3 methods actually abstract methods. So there was no implementation of the behavior that is defined. Okay, so through abstract class we just specify there are 4 functionalities that has to be done, and 3 functionalities are just given, and 1 functionality, how the functionality will happen, that implementation has been given. So the percentage of abstraction that we are achieving here is 75%. So out of 4 methods, 3 methods are abstract. So 75% of abstraction is achieved. Okay. And whenever you have an abstract class, because we cannot instantiate that abstract class, this abstract class must be extended by some other class. Now, for example, there exists a bank X, and this bank X actually wants to have the ATM. So then what it will do is it extends this ATM. Now it is the responsibility of this bank X to have implementation provided for all these abstract methods. This is what actually happens whenever you have an abstract class. So there should exist some class which is interested in this particular abstract class. It can extend that. Whenever it is extending it, so all the abstract methods have to be implemented in this particular child class, and an object of this particular class can be created to have the behaviors of all these methods. This is how it has to be done. Why it has to be done? So this is how we are managing the complexity. So there is an ATM, so there are certain functionalities that have been defined. Now whoever bank wants to have an ATM can implement that. So if at all you want ATM, so these are the 3 mandatory methods. These are all 4 mandatory methods. 1 I have implemented, rest of the 3 you can implement in your own way. That's how the ATM specification tells us. So here ATM abstract class is actually providing the functionalities, and the class bank X actually implementing this. So here there is a relationship that exists actually called a realization relationship. So in realization, what happens is one entity takes the contract, one entity actually gives the contract, and other entity guarantees to execute that particular contract. So class actually guarantees for execution of this one, and here it provides actually the contract. In the contract it specifies these are the functionalities, and the other entity guarantees to provide those particular functionalities. So this is actually called a realization relationship. Whenever we are modeling the solution for a problem, when we find there are some entities where one actually provides a contract and other guarantees to execute that contract, then we should actually have a realization relationship. That can be actually possible in Java with class and abstract class, and otherwise class with interface. Abstract class and interfaces will provide the contract, and classes actually here in Java guarantees for that particular contract. Okay, so this is one example. And if you see, I have another example for this abstraction. So now there is an interface called RBI, and what RBI tells is it actually defines the specification for ATM. What it says is, for an ATM, so there should be some functionalities like check balance, withdraw and deposit. That's it. Now there are a number of banks that exist, and a bank wants to have the ATM, so it applies to the RBI. Then what RBI says is, okay, you can have an ATM, and these are the functionalities you must and should have in that particular ATM. Now what this bank will do, this class bank, some Y, implements this RBI interface so that all these abstract methods have to be implemented over here. Okay, so when you are writing an interface, the keyword abstract is not required. Implicitly they are considered to be abstract. Okay, so implicitly they are abstract as well as public. Okay, so we need not to specify abstract. By default they will become abstract in interface. Okay, so here the bank X or bank Y has a responsibility for implementing all these methods. So implements is the keyword, and the interface name has to be specified, and all these methods have to be implemented along with these methods. And this class can have its own methods as well. Okay, so this is actually a contract, and somebody guarantees for executing that particular contract. And interfaces will achieve full abstraction. So that means 100% abstraction, because interface contains all abstract methods only. Okay, so in Java we have two entities with which abstraction is achieved, are abstract class and interface. Abstract class achieves 0 to 100% implementation. That means abstract class has all concrete methods, then 0% abstraction. Abstract class has all abstract method, then 100% abstraction. Otherwise, some abstract methods and some concrete methods, so maybe some 30, 40, 50% of abstraction. Whereas interface, if you see, interface will contain all abstract methods only, through which we will achieve actually 100% of abstraction. But the point here is how abstraction is helping, how it is actually can be mapped to a real world scenario. The first thing is abstraction helps us to solve complexity. Okay, and it focuses on what to do rather how it has to be implemented. The example which actually I am relating to a real world is, as an example, a bank wants to have an ATM, and all banks are controlled by RBI, and one will go to the RBI and apply for the ATM. And RBI says, okay, you can have the ATM, but these are all the functionalities of the ATM. Now it is the responsibility of that bank to have all those methods implemented in it, because it wants actually that ATM, and ATM specification was defined by its controlling body. Okay, So now the interface RBI specifies what to do, and n number of banks who wishes to have the ATM can have their own implementations. Some bank X will implement all those methods in own way, but it should guarantee that all the functionalities are available over there. In the same fashion, other bank also has to implement all the methods, and other bank also, like that n number of banks have to implement all these things. So that's why if you observe, if you go to any ATM, irrespective of the bank, you will find the uniform interface. All ATMs will have some minimum functionalities like withdraw, deposit, transfer, check balance, min statement, and pin change. Why every ATM has the same interface? Why not they're differing like their net banking? If we go to a bank's net banking and we visit other banks' net banking, so both are completely different. They have their own features, interfaces, etc. But whereas an ATM, you have unified interface for all the banks. That may be a commercial bank or nationalized bank or a private bank, whatever it may. The reason is because somebody specifies. So that is nothing but abstraction. Some functionalities are specified. So in order to specify that, you have an abstract class if that particular specifying body implements partially. Otherwise, there is no implementation and everything is a functionality, then that becomes an interface. So this is how an abstraction is achieved in Java with the help of abstract class and interface. I hope the abstraction concept is understood, and it is one of the principles of object-oriented programming. So if you like this explanation, please like, share, and subscribe to my channel. Thank you. Thanks for watching.